Yes, in this video we are going to discuss about the CNC path programming, drilling and boring experiment. Okay, so here the program, what is the aim of the program is write a path program for the drilling operation in the lathe. The given sketch for the given sketch we have to write by using a peg drilling cycle and a step boring cycle. So here what is the given size is the 60 length, it is the 32 raw material it is given, and in that we are going to make a hole. So we can see in this diagram 12, 15 and 20, the three different diameters are given. For that we have to make the holes here, and for the distance here it is 20 and it is 10 and here it is 5 that's what. So totally for this 12 diameter it has to cross for 20 plus 30 35 and this 15 diameter should come for 30 and this 20 should come for 20 So this is what the sketch. For this sketch we are going to write the program. So here let me see the program how to write. So this is the sketch. So this, for the sketch we are going to first of all we just imagine this is diameter 16 12.5 and these are all not required for us in writing the program because it's a drill bits. So standard drill bits we are going to use, and the dimension is approximately it is given as actually it is 12.5 and 15.5 or something. The diameter of the tools, exactly the drill bit is not exactly that one, so it is near to that. Okay, let me see in this. First of all, write the program for this. Let me draw with the program number. Okay, anything will start with the OG0, that is the program number letter with O and a 4-digit number. Then this billet size, it should be in a bracket, and a bracket should be there. So and metric data input feed per that is per minute, and tool position which is in the reference tool position. See here the tool should be in a turret holder. The tool is there, which tool number, that is I am going to select a tool number 1 where the drilling tool is there. Okay, so in here we can see 12, 15, 20, the three different tools are there. So I am going to select one by one. So first let me do for 12 and 15 then we are going for a boring. So and moreover this is for center bit. Let me do with a center drill bit, then we will go for it. So central drill bit we can use just 5 distance. For little 5 distance we can go for by using a center bit. First bring the tool. This is the N03 spindle rotation starts, and bring the tool to exact. This is the raw material. So raw material here, the drill bit has to come to this position. Okay, this is the drill bit. Okay, this is the drill bit or center bit. So this is exactly, this position is x0 and z0. Okay, this position is x0 z0 position. So I am bringing the tool to this position, and then we have to make the drill here. So x0 is z2. Just I am stopping the tool 2 away from this, and then I am going to make the drilling for 5 So minimum for 5 I am taking. So just for the center bit, and then I am going to select another tool which is there for making this hole for 35 Okay, what is the 35 is? This entire drill I have to make from this point to this point. So this entire travel, a drill bit has to travel, that is the 12 diameter drill bit I am going to use here. So this drill bit, but it cannot travel for at a stretch, so I am going to use the peg drilling cycle. This is called the peg drilling cycle, where peg by peg it is going to be doing. So the peg drilling cycle says x, z is the coordinate points, where is the final coordinate points, and depth increment in microns. So how much depth there is for entire, see 35 this 35 instead of moving at a stretch I am going to use 55 So this is the 5000 as the microns. So this 35 will be in terms of 55 it will go, and it will take until this. After completion of this, we will go to home position and select another tool for the boring. Okay, this is now the job is done with only this up to this 12 it is done. So a hole is done. Then this boring, step boring we are going to do in the reverse direction, that is we are increasing the diameter from 12 to 13, 14, 15 for a distance of 30 mm. After from 15 to 20 we are going to increase for this. So by using just like box turning, we are going to use this G90 X12 is at minus 30. So from here, this for 30 mm, from X12, X13, X14, X15, like this diameter is getting increases until X15 for a distance of 30 mm. Then only for 20 mm I have to increase. This is for from here 20 mm, this 15 to diameter 20. So diameter is increases 16, 17, 18, 19, 20 for the distance of just only 20 mm. So from at this distance it is increases from 16 to 20. Finally G28 U0W0 M05 M30. So this is how we are going to write this program. So just boring cycle, we are going to use the box turning cycle. How we are use the external step turning, like this here internal we are increasing the diameters. So this same G90 will be used there in this case. So after that this is the program for simulation. We have to go for the simulation, how it is to be done in the case of simulation, right? So once this is done, then we are going for the simulation. The lathe, once the simulation we have finished this lathe drilling operation. So we are going to, after completion of this program, we have to show it in terms of in the lathe drilling operation. So what I am going to do is selecting this CNC term, and again we are going to copy paste. This is create a new part here, go OK, and now we are going to type this program here. Either we can type the program like this, here also we can type the program, or we can copy paste what it is already we have done here. So this is the step turning. First I am selecting this, Control C and Control V. This is first, and then another tool for second tool. This is the second tool. So enter here. Then I am going for the third tool, where it is the next slide. We can go for the third tool. So all should be written in the same continuous sequence. No need to give blanks and all. So that is a common. So let me check it once. The program number is there, the let size is there, D2198, home position, tool number 1. Okay, this is one tool number, and here you can see another tool number and another tool number. 3 tools we are going to use. So first is for just for center bit, and second it is used for the 35 mm length. That is, we are making a drill for 35 mm length with the 5 microns. Okay, 155 microns. Here we can go for 1000 microns, since it is just for 5 mm, and here 5000 microns I have given. And once this is done, then we are going for box turning. Why? Because this drawing we can show here. So here the drill bit comes, until this the drill bit comes, but here it is just a step turning. It's not drill shape. Here you can see that. So it's a 15 mm to 20 mm. It's a step bore. So we have to go for it, and the drill bit size, you can see whatever it is they said, we can use it. And now we will go for, once the program is copied here, as we discussed, we have to go for what is the size. Billet size is 32 and 60. The raw material is 32 and 60. So going for, you can reduce this by clicking the mouse here, blank, 60 mm length and 32 mm diameter. Okay, starting from 0 only, always it should be 0. And the machine, we are selecting the machine, type A, and go for syntax. Let me check the syntax. Here it shows one warning. What is the warning? Invalid code of this. So where it is there, then we have to remove it. If there is any errors comes, then it is a problem. Warning, actually it's not a big problem. So right, so don't If possible, you just once again check it where it is there, right? So warning invalid for line 2, it is there, that is okay. If it is not required, we can remove it and we can go for syntax. Let me check it once again. It will show 0 error and 0 warning. That's it. So now three tools are there. One is the center bit. So central grid bit, I am selecting this just for making a small 5 mm drill bit, just for 5 mm thickness it will be there, and for depth. And then I am selecting tool number 2, twisted drill bit. What is that? 12 mm diameter. Almost it is 12, but it's 12.5. Okay, I am selecting this 12.5 diameter. And then boring, we have to go for the again internal groove. This is what we called as internal groove, or we can have this internal groove is like this, it will come. So external groove, how it will be different, and internal will be different. So we can select this internal, so that you can get like this, the tip width, and these are all will come like this. So internal groove we can do it, or bore we can do it. So here, what is that tool? It is given drill tool and twist, insert, drill. These are all the things out there. So we have to we can't go for external thread or internal thread or any other things. Okay, so internal turning, we will get internal turning here. This is a boring operation. So we can, the grooving is different. Now we are going for a boring operation. So the boring, I'll select just like the previous cases. We can select some tools and we can reduce the nose radius for better finishing. Okay, so this is the bore, but in this direction we have to make it, right? We will make some tools like this. Okay, so the point nose radius I am going to reduce 0.2 nose radius. Okay, total tool holder length and all, everything is there, no need to change anything. Okay, give okay, then go for syntax once again for any changes, whatever we have done, it is that, and give okay. So this is, you can see how it is, because of this diameter it shows like this. So this much should not be there, that's what it shows, what mistake we are doing. So here, what is the size? It is given for internally is 20 mm. So if a bore has to travel, in the sense it should be less than the 20 mm. So that's what, when we are selecting the tools, we have to be clear of that. Okay, so when we are selecting a wrong tool, internal we are going for internal boring. So here we have to select what is the size of it. So if you select a smaller one, then we can get it. Otherwise, the size, you can see the holder diameter is itself 20 diameter. Holder diameter itself 20 diameter, in the sense we will have a problem over here. So the holder diameter, it should be less. So 10 mm diameter here we can see, like that we can select. So if holder mm is 10 mm, then obviously let me check it with the syntax. Now play. So the boring, now it is going to be take with this boring tool. So this is the final one. So that's all. Now we have finished this simulation. So this is the simulation where this entire drawing has been done as a, so the result is a simulation has been done for the given sketch. We are going to write the simulation has been done for the given sketch. So this is the sketch and this is the simulation. Okay.